Using K-map, simplify the function. So we have been given this function. The summation of miniterms of 3, 8, 12, 13, and 15. So the letter M here indicates miniterms. So that is how we pronounce it. This is miniterms, where we have 3, 8, 12, 13, and 15. Actually, K-map is a wide topic to some extent, but most cases the question asks about the miniterms because we have what we call the max terms, where we represent with pi, and we have also the don't care terms, where we represent with d. But most of the time we have these kinds of functions when you look at different papers. So here we shall draw, as you can see now from here, when we have 3 and we have 15 here, it means the possible combination of the inputs that we shall have will total up to 16, because from 0 to 15 is a total of 16. So we shall have a 4 input. This is a 4 input truth table, which now we shall be representing it using a K-map. So let's draw a K-map of 16 squares. So we draw as a 16 square K-map. So we have one, we have the second one, we have the third row, we have the fourth row. So we divide it to have 16. So that is our K-map with 16 squares. Now we are considering inputs A, B, C, D because of the 16 squares, and this is because of this 15 here, which is indicating that this will be a 16 square K-map. Because when we take the formula of 2 power n from 2 power 1, then we go to 2, that is 4, to 8, that is 8, and to 4, we'll find that it is 16. So for a value of 15, we expect the K-map to be a 16 column or 16 square. So now here we shall label all possible combinations of these 4 inputs, whereby we normally have we normally label like this. We start with the 2 with AB at this side. We combine all possible combinations. Let me write here. So at this point we shall have A and B combined negative, then we shall have A negative B, then we have AB, and then we have A, then B negated. Then here we shall have C and D both negated, not C and D. Then we have C and D, and we have C and not D. So here our columns are appearing to be more, so we shall reduce this. So we reduce that one, and this one will now be a 16 square came up, where we have 1 2 3 4 times 1 2 3 4, that is 16. So we label like that. Then the next thing is to indicate how to indicate these values given in the function. So when we have a and a b here indicated as negated, it means they are at level 0, at 0 logic level. So at this point now here, they are both at 0. Here a is the one which is 0 and b is 1. Both are 1 here, and here 1, a is 1 and b is 0. Negative means 0. Then here, on this upper side here, we have from both here 0 0. Here we have 0 and d is 1. We have 1 1 and we have 1 0. So that is how to label. This labeling will help you now to indicate the particular values which are given in the function. So now after that, you look at every square and you try to combine these binaries and see the equivalent value. So at this column here, at this square here, we have to combine this binary these two groups of bits, and we see the equivalent value, which is now 0 0 0 0, which is equivalent to 0. The next one, we combine this 0 and this 0 1, and you will find that at this column the value is 1. When we combine the other one, we get 0 0 and 1 1, which is equivalent to 3. When you look at this, it will be a 2. This will be a 4, because of we start with this side. So you start reading this side and you combine with this. So this will be a 0 1, then 0 0, and this one is equivalent to 4. So that is 4. This is 5. This is 7, 6, 12. This 13. This is 15. Then 14. 8. We have 9. We have 11, and we have 10. When you combine the way we have done it for the first cells. Now, after you label like that, now the values that appear in our function, where they are, you put 1. So at the point where the value appears in our function, we put a 1, meaning it is present. So let's do that. We have 3. At where 3 is, we put a 1. We have 8. Where 8 is, we put a 1. We have 12. We have 13. We have 15. So that is that. Then all the other positions we put a 0. So we put 0 to all other positions, such that now where we have 1, it is now where our function values appear, and a 0, the rest does not appear in the function. Now in this one, now after that, that is the K-map, but we have to group we have to group it. We group the ones and we come up with an expression. So when we group, such that we don't overlap anywhere. So the best grouping here, we can have these two ones here, and we have these two other ones here. Then we have this one being alone, appearing as a group. So we have these the following groups. We have the group where we have 12 and 8. We have another group which is 13 and 15. And we have the other group where we have 3. Now, in those various groups, we write the equivalent expression using the inputs A, B, C, D. So, for example, for this one, we have for 12, where 12 is, we combine this row with the column. So we shall get the expression AB, not C and not D. Then this one you add to the other combination of 8. Where 8 is, we combine this row and this column. So we shall have A, B, not B, that is not B, and not C and not D. So when you consider these two expressions, you have to look at, where possible, if we can simplify. And when you look at this, you find that in this expression, you find that here we have a B and we have a B which is negated. So we can apply the law of complementation, whereby we say if we have a B and a B not that is negated, these two will give us a 1. So we can factor out A, not C and not D outside. Then we have our B, then plus not B. So this will give us a 1 multiplied by S, not C and not D, which will give us a final expression like this. So for the group of 12 and 8, we get this expression, which is the simplified expression. Now let's go for another group, which is 13 and 15. For 13 and 15, 13 has the expression 13, we combine this, which is now our AB, and this column, which is not C and D. So we shall have AB, C, no, that is not C and D, and 15 as AB, then C and D. We have C and D. So the expressions, we had both of them. So we have AB, not CD. We add A, B, C, D. Now when you look at it, you find that the C can be cancelled, because when we factor A, B, C, D, then we shall have a C and not C, like that. And C and not C or not C, we get a 1. So we shall have A, B, D and 1. which will give us ABD. So that is the expression at that group point. Now for the 3, we just read the expression because we don't have any combination. So for group 3, the expression is not A and not B, then C and D. So after getting the simplified expressions for each group, you do the OR operation. You add them together. So now the expression for this particular K-map will be the first group 12, 8 is A, not C, not D. We add A, B, D, and lastly we add not A and not B, then and C and D. So that is the simplified expression for the particular K-map. So this needs a lot of practice. So you can look at more examples so that you may get the concept.